Today I will give a brief description of climatology, and in the climatology I will explain the pattern of wind. As you know, the earth has come into existence 4.5 billion years, and sun has come 4.6 billion years, and it is revolving around the sun at this time. And with the passage of time, the earth has evolved, the atmosphere has been evolved around the earth. As you know, in the atmosphere we have 79% nitrogen, 21% oxygen, and the other gases, and also the water vapors, depending upon the what at which part of the earth it is the air is present. Now you see, this is the map of the earth. Okay, and here I have made it in a through 2D. This is a 2D model, and this is a 3D model. Now you see, this is our equator. Our earth is rotating from anti-clockwise, west to east, and at the same time, you see, this is the earth. See, this one, as you know, this is our solar system. In the center is the sun. The first one is the Mercury, then comes Venus, then this is the earth. Earth is revolving around the sun anti-clockwise. This is anti-clockwise. Every planet is moving anti-clockwise. If you look from here, it is opposite to the movement of the needles of the watches. Okay, the main thing is the earth is revolving around the sun, and there is a plane here. This is the plane, but the earth is just inclined toward the sun, 23.5 degree. It's not revolving like this. Like you see, this is the pole. This is the pole. This is the pole. This one, and it is not revolving like this. If had been like this, there would have been no season, no weather on the earth. Now you see, because earth is inclined like this, it is revolving, and it maintains its inclination toward the north pole. So this inclination 23.5 degree give rise to the weathers. As I told you before, this is a 3D model of earth. This is the equator, and this is the north pole, and this is the south pole. And in the north pole, from the equator, if you go toward the north, this is the pole, the latitude is increasing. This is the 0 latitude, then comes 30 latitude. If I advance more toward the north pole, it is 60 latitude, and the north pole is 90 latitude. Okay, this is just a brief description about what are the zones on the surface of the earth due to the sun rays, due to the temperature difference. You see, this I show you. This one is the equator. This is the equator line, and just 23.5 degree. This is the line. This is latitude is increasing. If I go from here, it is 0 latitude. This is 30. This is 60, and this one is 90. From equator up to 23.5, this area is known as zone of Cancer, Tropic of Cancer. And on this south side, up to 23.5, this is known as Capricorn. Okay, so these area from 23 north and 23 south, this is known as tropic. tropical zone, you can say. From here it is tropical zone. The maximum sunlight fall on this area, this one. Now I will tell you here. Now see, this is the equator. This is the 0 degree latitude, and most of the sun rays, they fall on this area. This is, I told you, this is the tropic. This is the area zone of tropic. 23 north, 23 south. Maximum the sunlight falls on this area. This is known as insolation. So what happened? This is the ocean. This white is the continent. Mostly the ocean water, this get warm because the sunlight is falling on this zone throughout the years. Okay. Now see, when the sunlight will fall on this area, what will happen? The water of the ocean, what will happen? It will evaporate and go into and will be converted into water molecules. So water molecules, the warm water molecule, their distance between them is more, so density is less. So what will happen? This water vapors with the nitrogen and the oxygen, it will rise because it is lighter and warm and humid. It will rise because why it is lighter? The number one is lighter. Number one is heat, due to heat. The other is see, when there is a nitrogen has molecular weight 28, oxygen has how much? 32, and the water molecule has 18. So when the water molecule add up, so this is now the air is a little lighter. One is it is warm, the other is it is lighter, so it will rise up. It will rise up. Especially it will rise. This is 5 degree north. This is 5 degree south. This it will rise at 5 degree north, not exactly at the equator, because this is a very calm zone. This is known as doldrum. This I will tell you later on. What is doldrum? This is very calm area. Just 5 degree north, the air is rising. I told you this I have made this. You see, I have made this arrow. The air is rising. The higher we go, the cooler it is. So what will happen? The water vapors will condense at higher latitude. After the dew point is reached, when the air will be fully saturated, 100%, the air parcel will rise up. So what will happen? The parcel of air will get cool down and will condense, and the water vapor will be formed and the cloud will be formed. Cooling, condensation, and cloud formation. So at the top height, 15 kilometer above, there is always cloud especially on the surface of the ocean. Maybe if the air is humid, also on the continent, always there is a cloud at the equator. Okay. Now at 15 degree, the clouds are formed. Now the air has this much molecule. It is cold. Now before it was having water, so it become light and also heat. Now the air has gone up and water has condensed. Now the molecule is this one. It is 60. Before it was 78. So this air, okay, now it is very cool. Now what will happen? It will be diverted toward the pole. It will be diverted toward the pole, because on this side the same thing is happening. 5 degrees south, the air is rising because it is warm, and it will go on the south side. We are talking on the north side. The air will rise 15 degree, cloud will form, air become condensed and it become cool, so it will travel toward the pole side. Okay. Now what will happen? Because you see, when the air will rise from here, so there is a gap here, the pressure will reduce to fill this because air is going up. So this is here the air is less. To fill this gap, what will happen? The air from the pole will cover this low pressure area. Now you see the air is going up, at the same time this air is coming on the equator side, and you see this air will go on the pole side upper. When it will come here in the 30 latitude, it will sink because it is cool, and it is the cool thing is heavy, density become more, so it will sink on the 30 latitude. Now you see the air has rise from here, okay, move toward the pole side, and at 30 latitude it is sinking. So if it is sinking, no, it is being divided into this portion. This is known as trade wind. This is known as trade wind. Before when there was no motors and generators, people used to travel or used to do business by this trade wind because there was no motor. Okay, so it was traveling by the wind current. Okay, so have you seen this, the air going here, moving towards the North Pole, sinking, and again going here. This is a cell. Have you seen? This is a cell. Since the earth has come into existence and it has attained the atmosphere, okay, so it is moving, this cell is moving, maybe billions of the years it is moving. This cell is known as Hadley cell. What is this known as? Hadley cell. One cell is Hadley. To memorize this, Hadley, H is for heat. So most of the heat is in the equator. This is Hadley cell. Okay, now you see, I told you before, this air will sink here. Okay, either it will go toward the equator, either it will go toward the pole. This air which is going toward the pole, this is, I told you, this is the trade wind. This is known as westerly because due to Coriolis effect, this air is not directly going toward the pole. It is diverting toward the, it is diverting air, this is air, it is diverting toward the right side on the north hemisphere. This is due to Coriolis effect. Due to Coriolis effect, what is this? Coriolis force. The Coriolis force is due to the spinning motion. You see this earth is spinning. This is spinning, and this one revolving around the sun. This is revolving orbital motion, and this is known as spinning. Due to spinning of the earth, what happened? The Coriolis effect is produced. This need a lot of explanation. I will be having a different lecture, a separate lecture to explain what is Coriolis effect. But on this side, what will happen? The air will be shifted or deviated toward the right side. Okay. Now you see this air is going, this air is sinking, and this is a high pressure zone. This is the high, because air is going on this one area, so it is being compressed. So this is known as subtropical high. This is known as the air. You see, I told you air is, I will make it with the blue. You see, the air, this is the equator, the air going up, okay, going toward the pole, then sinking at 30 latitude. This cell, I told you, this cell is known as Hadley cell. Okay. Also, because here the air is sinking, so this has a high pressure. What is this, sir? High pressure belt, you can say. From here, when it fall, it will either the air will go here. It cannot go penetrate the earth surface. Either it will go toward the equator, either it will go toward the pole, toward the pole. The air which is going toward the pole, now see when air will dip here, this is known as subtropical high. What is this? Subtropical high pressure. Okay, this subtropical high extend from 23 north or south to the 35 north. This is a separate classification. I told you this is the tropical zone, and this a little 10 degree or more to 12 degree. This is another classification, subtropical zone. Otherwise, this all area from here to here, this is known as temperate. This is known as temperate zone. This is known as temperate zone. We have three zones: subtropical, we have tropical zone, okay, in the equator, around the equator, 23 north south, and then we have the temperate. Temperate has been further divided into subtropical. Leave it. We'll go simplified. Temperate zone. Okay. Then from 60, actually it is 65. From this area, this zone is known as polar zone. What is this, sir? Polar zone. This is the third one. Is 1, 2, 3. The major classification is near the equator is a tropical zone. Then if we go toward the pole, this is a temperate zone. The third one is a polar zone. Now we will come to our point. The air which is sinking here, just at this particular point where that air is touching the ground, this is also known as horse latitude. Horse latitude. What is this known as? Horse. This is known as horse. Why? Because here there is no motion. If you go into the ocean, when you pass to this area where there is a high pressure, air is sinking, your boat is, or your ship is struck. It is not moving toward the north side, neither it is moving toward the equator, so it is stuck. So that's why known as it is harsh latitude. Why it is harsh? Because previously people used to go when they encounter this area, subtropical high, because the boat is struck, it's not moving. So what they happen, because to reduce the load, they used to drop the horses into the sea. Because if the boat is light, then you can use your this gear, manual gear. Otherwise you cannot, because it's so heavy. So people used to throw the horses into the sea just to reduce the weight. That's why it's known as horse latitude. This is, you can say it is 30 to 35 north or south, horse latitude. Okay, now you see the air is falling here at the horse latitude, 30 latitude. Then air is going on this direction, on the pole side. Either it's going toward the equator. This air which is going toward the equator, this is also diverting toward the right side, because there is a Coriolis effect. This air is not going straight air is going from here, it is diverting toward the north side, deviating. Why? Due to Coriolis effect. Now you see, this is trade wind. This air, because it is coming toward the west side. If you see here, the air is coming, this is coming from the west side. This is the west side, this is the east side. This is east side, this is the west side. So this air, because it is coming from the west side, it is known as westerly. What is this known as? It is known as westerly. This air is known as westerly. This was the trade wind. See, this is if you look into here, you see this one is the trade wind. This is trade wind, okay, and the air going this direction toward the pole is known as westerly. What is this known as? Westerly, because it is coming from, it has a little inclination coming from the west side. Okay, now you see this air which is going toward the pole westerly, it rises at 60 latitude again. At 60 latitude it rises again. This rise is not due to the due to that it is warm. No, this air was rising because there was sun rays here, the water was warm, so the air become light, so a light thing rises. Okay, but here the air is rising because it is due to centrifugal force of the earth, because earth is rotating. You see, this is earth. If it is rotating, so something here, it has a tendency to go outside. Anticline. This is 60 latitude. When the air is coming from here westerly, and on this side coming polar wind, cool and dry air. This air, which is known as westerly, this is humid and little warm. Okay, this rises from here. This will rise from here. This rises due to centrifugal force, due to the spinning of the earth. See, air is rising here, but this is due to temperature. But here it is rising again. This is due to centrifugal force. So this air is rising, and again at the this will rise 15 kilometer, but this air will rise up to 8 kilometer, because this is very warm. That's why it goes up to 50 kilometers. This air at the 60 latitude, it go up to 8 to 10 kilometers depending upon the season. When the air coming here, it will go here. Above is the stratosphere. At the top, what is here? Stratosphere. The temperature difference is same, straight, bilkul. That's why air will either go here, either go on the pole side. When the air will go on this side, this air go here, it will again sink at the horse latitude 30, at the 30 latitude, okay, sub tropical high. So it is going, air going here, sinking, again going here, going here. It is, see, this is also a cell. You see, this is a cell. You see this air sinking, going here westerly, then again at 60 latitude rising up, again dividing either here or here. So this is a cell. This cell is known as Ferrel cell. This is known as Ferrel cell. There are, I told you, Hadley cell. This cell is known as Ferrel. This is a scientist, Ferrel cell. Okay. This is the Hadley cell. How you will memorize? From H from heat. So this is Ferrel cell. Now you see, when air will on the top, at 8 to 10 kilometer, it will divide. Either it will go toward the equator, either it will go toward the pole. The pole air will again sink here. When it will sink here, and it will go toward the 60 latitude again, it will go again toward the equator. See, air rising up, going toward pole, sinking at pole, then again going here, again rising at 60 latitude. This is another cell. This is known as polar cell. What is this known as? Polar cell. This is polar cell. So we have 3 cells. This air, the motion is like this. This motion is like this, and this motion is like this. This you can say this is what is this? On the north side it is clockwise, and this is anti-clockwise, this is clockwise. The same is happening on the south side, also 3 cells. Okay, so so today I have tried to make it very easy to use a minimum terminology. So this air, these three cells of air which is revolving since the earth has attained the atmosphere. So this was today's lecture. Please see again and again, and you will have a concept. Three cell are here, three cell is here, and this is going on since billion of the years. Okay, this is our atmosphere where we live. This is known as troposphere. All the weather phenomena are here. Then on top is a stratosphere. Then come the stratosphere where there is a ozone layer. Then there is a mesosphere. There is meteorites are falling at night. Okay. Then there is thermosphere, where is our ISS, International Space Station, is in the thermosphere. Also these aurora, northern lights, southern lights, lights falling from the sky, this is also in the thermosphere. Inside the thermosphere there is also ionosphere. Okay. Okay. Please see again and again and have a concept of three cells, three pattern of air around the earth.